Start.
1 minute. Hi team, I'm Sahajapriya and my group number is 23. I would like to give presentation on a roadmap of artificial intelligence. To commence with, I would like to give the general definition of agent. Agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Coming to sensors, it is a device that detects or measures a physical property and responds according to it. Actuators are nothing but the output generated by the environment. They are responsible for moving and controlling system. Agent-based view offers a powerful tools, techniques to implement many types of software which is used for world. Agents are now widely used in variety of applications ranging from personalized email filters to air traffic control. But certain aspects of agents are dangerously overhyped, which should be stopped further. The definition of agent is um for now, agent is a computer system situated in some environment and that is capable of flexible autonomous action in order to meet its design objectives. There are three concepts of definition. Um Next slide. One second. Okay. So there are three concepts of definition is situatedness, autonomy, and flexibility. Situatedness means agents receive sensory information, sensors input from its environment, and perform actions which change the environment in some way. Autonomy means the system should be able to act without the direct intervention of human and should have control over its actions and internal state. The best examples for this are any process control systems like thermostat and software daemon. In addition, agents should also possess flexible characteristics, which mean systems should be responsive, proactive, and social. Um, Next slide. Coming to agent-based system, it is internalized in terms of agent, but implement without any software structures corresponding to agents at all. For instance, an object-oriented software, it is responsible to design a system in terms of object, but for implementation, there is no use of object-oriented structure software environment, which is ineffective. Similar situation exists with agent technology. Hence, agent-based system both combination of should be designed and implemented with the combination of agents. Agent-based system may contain one or more agent. A good example of a single agent is expert assistant, which guide user to complete task in a computer. Coming to multi-agent system, the system is designed and implemented as several interacting agents, such as cooperation, which means working together towards a common aim. Coordination is organizing problem-solving activities. Negotiation is coming to an agreement which is acceptable to all the parties involved. Move to next slide, please. The main topic here is autonomous agents. It is an intelligent agent operating on an owner's behalf, but without any intervention or interference of the ownership entity. The main contributors for these agents are artificial intelligence, object-oriented programming, and concurrent object-based systems, human-computer interface design. Um, Next slide, please. Coming to AI planning pattern and its architecture, AI is all about building intelligence artifacts that can sense and act in some environment. Then they can be considered as agents. During AI research, uh, autonomous agents was closely connected to AI planning. As AI planning is the subfield of AI, it knows what to do and what actions to perform. Ultimately, the agent is just a system and it performs actions in some environment. So AI planning pattern is commonly associated with a STRIPS planning system, which is a symbolic model for agent's environment and a symbolic specification of the actions available to the agent. It has a planning algorithm which take input representation of the environment, and set action specifications, goal state, and gives output as a plan. So the planning system decide how to act from first principles, and also in order to satisfy a goal, they first create a new plan for the goal. Previous slide. This AI planning primarily focused on the planning algorithms, which can be predicted on the assumption of calculative rationality, and it is found very unrealistic. Because in calculative rationality, the output is said to be optimal if the agent is performed action at the time of the agent began its decision making. So this perform is unlimited, and it has unlimited searches for the space decisions. So the size of the searches is exponential. So it is not viable option for the agent preparation. Hence, the alternatives was proposed by various researchers. One of the alternative is a subsumption architecture, which is proposed by Brooks, that has no symbolic representation, and it is a collection of task accomplishing behaviors. Each behavior has a finite set of machines that maps input to output, and the decision is made by the interaction between the behaviors, which is the biggest failure of the system. So it has led to or focused the shift to hybrid approaches, which is a combination of both first principles and subsumption architecture. Uh, the final tradition in the area of agent architecture is practical reasoning agents architecture. These architectures are modeled by the theory of practical reasoning in humans. Here, the behavior is understood by the attribution of attitudes such as beliefs, desires, and intentions. This architecture is also known as belief desire intention model, where belief is the information about the environment, desires or the options available to the agent, intentions or the possible states of affairs that agent may choose. An agent practical reasoning involves uh, repeatedly updating beliefs from information in the environment, deciding what options are available, and acting on the basis of intentions. Next slide, please. Uh, and the second contributor for the AI planning is object and the concurrent object system. Uh, the object-oriented programmers often fail to see new ideas regarding agents. Objects are computational entities that encapsulate some state and are able to perform actions on this state. There are clear similarities between the objects and agents. At the same time, there are many differences between them. Coming to the first one is in the degree to which agents and objects are autonomous. It is a question. So, in object-oriented case, the decision lies within the object that invokes the method. In agent case, the decision lies with the agent that receives the request. The second difference is object model has nothing to say about how to build systems that integrate behavior. Third difference is that agent systems each have their own thread of control, whereas object oriented doesn't have a single thread of control, but it has a concurrency in object or oriented programming language. Coming to human computer interface, here computer performs what the user tells to it directly. So it is nothing but direct manipulation. That means computer program will do something if it is explicitly told to do. It would be desirable to have a computer programs that take initiative rather than doing whatever the user tells. Um, and moving to the next topic is multi-agent systems. Um, it is traditionally divided into two two main streams, that is distributed problem solving and multi-agent system. Distributed problem solving consider how a particular problem can be solved by a number of modules, which divides and shares knowledge about the problem and its evolving solutions. In contrast, multi-agent system is concerned with behavior of the collection of pre-existing autonomous agents that is aiming to solve a problem. There is a concept called the actor model. It is one of the multi-agent problem-solving model. Actors are proposed as the universal primitives of concurrent computation, and it is self-contained, interactive, autonomous components of a system. There is a protocol called contract net protocol. In this protocol, agents can dynamically take two roles that may be manager or contractor role. The protocol enables dynamic task allocation and allows agents to bid multiple tasks at a time. And also it provides natural load balancing. And the next slides will be continued by my teammate Sai Priya.
Yeah, hello team. My name is Satya Sai Priya. Today I take up my these applications. Applications is nothing but it's divided into two types. One is the industrial application and commercial applications. Industrial application is a invention of being process. It's an economic activity. These activities are divided into four types: process controls and telecommunications, air traffic controls, and transportatory systems. And coming to the commercial applications, these are mainly used in Windows operating systems and MS Offices, business programming wise. And coming to next topic is multi-agent learning engineers. Multi-learning agent engineers means nothing but those agents designed to learn viewpoint in various specialists. Those are categorized into cooperative and competitive. Cooperative means work together in the get the reward. It's a considered as a team reward. Coming to cooperative, competitive means it's a get another get reward. It's actually shared agent group of agents, like a third party mixture of both agents can do. And coming to the why multi agent learning, basically multi agent learning is this implies decided to force a multi specialist structure as a plan approach. In this Nash harmony conditions, according to viewpoint of every individual part. In this multi-agent learning, it's a descriptive, predictive, like engineering. These are categorized into defining the game Nash equilibrium, and then there's performance, coverage, and averages. Coming to the defining the game, it's a proper categorized game. In this game, utilized the applying the multi-specialist learning arrangement settings. Coming to Nash equilibrium is the Nash equilibrium example, like we assume like two players, like X and Y. Both players are same strategy but different purpose, but this game both are unknown their strategies. So this game finally succeeded, like it's proven the Nash equilibrium. Coming to that performance and coverages, it's an example, like in this performance, player first decided the decision, afterwards realized that other players move. It doesn't choose either players conduct, or finally the result is Nash balance. That performance, they calculate the averages, and performance wise, like the two players, everything is different players. And main topic is the engineer's agenda. Engineer's agenda, first and foremost, they set the goals like step by step, meeting array objectives, notable changes, and point every point they discuss and organize the goals, and set a points, and team members also up to date their goals, how to move their goals, and team members all together to take an action items. In this present creators perspective, the framework frequently pointed the principles on this in these agendas. Please let me know any question and answers. Yeah, thank you.